So this is the SLO problem, the student learning outcome problem for this class. There's several of them. This is the third one. Yeah, it would be the third chapter. So this will be one that's guaranteed on the test. It's actually pretty straightforward. It goes like this. The population of a town of 6,000 people, say dollars, in 1970 and grew to 9,000 in 1980. So that's over 10 years it grew by 3,000. Assume that the population will continue to grow exponentially at the same constant rate. What will the population of the town be in 1990? Now, if this were a linear problem, we could just add 3,000 to this and say, oh, well, it'll be 12,000. But it's not linear because we're told that it's exponential. So this hint that they give you is actually too much information. It's true that we could work it out like this, but if we look at an exponential problem, we have this equation where it is a sub 0 e to the kt. Or we could have p for population 2 and p sub 0. It doesn't matter how that's written. But there's an e equation. So basically we're saying that in 1970 we start with 6,000, and at 1980 we are at 9,000. So we have e to the k times 10. And this is how they're getting this relationship here, by using this equation. But I think that it's a lot easier if, in a better way, to just do the 9,000 divided by 6,000. What you find is that this is 1.5. This is how it's growing. So it grows every 10 years by this rate. And with exponentials, we actually multiply this. So for instance, if we did 6,000 times 1.5, we get 9,000. Now, that takes us over that 10 years. So this is what's happening, and this is in 1980. So if we take 9,000 and we multiply by 1.5, then we're going to get what's happening 10 years later. So let me type that in. Pretty easy to do, but that would be 13,500. So this should be the answer. It's really straightforward. I have it pulled up on my math lab, so let me just go over and get that real quick. So this is in 1990 because it's another 10 years. It's 13,500, and you're done. So what this is actually using a principle of is another type of problem that I wanted to take a look at, which is in number 4, where we're talking about this. In 2001, the median price of a house is $180,000. Assume the rate of increase is 6% per year. What can we expect the price to be in 2014? So how is this related? Well, it's still going to be exponential growth. In fact, if we take a look at this 1.5, and if we were to look at, I don't know if you recall, this annual growth rate, in this particular case, this would be a 50% growth rate, because it's like saying 1 plus 0.5 here. So for this home business, we know that it's growing, and I believe that was at 6% is what it said. So what we're going to do for this is we're just going to have this 180,000 times 1 plus 0.06, and this is the amount of time I didn't copy all that down. So this is in 2014. So if we start in 2001, we go to 2014, then that's going to be 13 to the 13th power. Okay, and if I put that in, 180,000 times 1.06 raised to the 13th power, then the home should be 383,927. So let's see how that holds up as far as our answer goes. And it's just to the nearest dollar. Seems like a lot of growth, but so be it. I guess I'm thinking more realistic growth. Like that doesn't happen. But that's okay. This is just a math problem, right? It's in math books. So yeah, that's what we need to do. Now, this leads us into the next one. Let's take a look at this. If you purchase a truck at $71,000 and then the company's truck is depreciating at 19% of the current value, what is the value at the end of the 4th year? So they're all kind of the same. For this particular one, you know, we've got our value of the truck. We'll just call it, we'll just keep it like this. We've started with 71,000 here. And this time, though, we're depreciating by, I believe it was 19%. Yeah, 19%. So we're going down by 19%. So that is minus 0.19. And this is the end of the 4th year. So we type this in and do 71,000 times, that would be 0.81 raised to the 4th. And at this point, should be 30,563. So let's see how that works. See if that works for our problem. And let's see, 71,000, 19%. I probably typed in the wrong value in my head. So let's see, 1 minus 0.19. No, 71,000. To the 4th, right? Okay, well, let's see what's going on, because this isn't a difficult problem. So I know that after the 1st year, it's going down by 19%. So that would be 81,000, or excuse me, 71,000 times 0.81. So 71,000 times 0.81, and that's going to be 57,510. I multiply that times 0.81 again. Okay, so if I do it again, so this is 57510 times 0.81. Then this is 46,583. And then I need to do that. So this is the 1st year. This is the 2nd year. And let's see. Times 0.81. Oh, and this was a 0.1. So this would be 37,732.311. And now I'm going to multiply this. So this is 3rd year. Now this will be my 4th year. Do this times 0.81. Okay, so it's probably just, I got the same thing, so let me just see if it's probably just a rounding issue. Oh, good Lord, it's to the nearest cent. Okay, so but either way, we'll get the same answer. I got the same thing for this as well, that this is 30,563. So I hope that helps when you're doing those problems.